So let's review for standard number 1. The first concept was combining like terms. What's the difference between number 1 and number 2? Well, first off, remember that we go left to right on problems like these. We don't add and then subtract. So for number 1, we would get 7 minus 3 is 4 plus 2 is 6. The thing that's different for number 2 is this variable x. And it turns out we now have two different terms. We have the number terms like 7 and 3, but we also have an x term because 2 is going to be multiplied by whatever x turns out to be. Can we combine numbers and x terms? No. So we take 7 minus 3 and get 4, and we leave it as 4 plus 2x. You can't simplify any further from there because they are two different terms. Numbers are often called constants, and x terms. What about when we have a second variable, such as 3 plus x plus 2y? Are any of these terms the same? We have a number term, an x term, and a y term. They are all different, so you cannot combine like terms. However, as soon as we add another term here, we see that we have a 3x and a 1x. Those are the same term. They are both an x term. How do we combine them? We add the coefficients, the 3 and the invisible 1 in front of the x here. So this could read 4x plus 2y plus 3. Why did I write it in that order? We start with the highest exponents first, or in this case, the variables, because we don't have any exponents. I listed them in alphabetical order, x then y, and at the end, the numbers, or constants. Here's the next problem. 2x squared minus 13 plus 2x plus 12 minus 2x. There are three different terms here: the x squared terms, the number terms, and the x terms. We usually combine these starting with the largest exponent, which here, that's the 2. This is the only x squared term, so there's nothing for it to be combined with. And then we move on to the x terms. I see there's a positive 2x and a negative 2x because the sign that is in front of the term matters. The plus here and the minus here. A positive 2 minus 2 just gives me 0x. I could write plus 0x, but I may as well not write anything at all. Watch out for terms that cancel each other out. Next up are just the numbers, and I have a negative 13 and a positive 12. If you paid close attention to the signs, when you combine these, you end up with a negative 1. So combining like terms canceled out the x terms, and we could combine the numbers. Here's another problem to practice how we combine different terms with the same variable. Notice we have y squared terms and y terms. We can't combine them though unless they have the same variable and the same exponent. So let's begin with the largest exponent, and we'll start with the x term. There's only one x squared term, so we can carry that down like so. Sometimes it's helpful to cross off the terms as you go. That way you can keep track of which ones you've already combined. Next up are my y squared terms, and I have two of them. Pay close attention to the signs in front of them, negative and positive, and it turns out they cancel each other out. Next up, my x term. I have a positive 2x and a minus 2x. Those also cancel each other out. And my last term here is a positive 1y. The problems on the test might be longer, but the exact same rules apply. The next concept from Standard 1 was distributing. An example of what this looks like is 2 times the quantity x plus 3. And what we do is we take this number 2 that is outside of the parentheses and we multiply it by each term inside of the parentheses. For example, we first take 2 multiplied by x. And that is pretty simple. You just put 2 and x right next to each other because that means 2 multiplied by x. We don't know what that is because x is a variable. Then we take 2 times 3 and we get a positive 6. So we write plus 6. And we're done. What confuses most people are the negatives. For example, when I distribute this negative 2 multiplied by 3x, am I multiplying two terms with the same sign or a different sign? They have a different sign. Here is negative, here is positive. So my answer is going to come out negative. 2 times 3 is a 6, and remember it's going to come out negative. There's only the single x term there. My next bit of distributing is a negative 2 times a negative 4. Do these two terms have the same sign? They do. They're both negative. So when I multiply them, it comes out as a positive 8. And this is my final answer. The third and final concept for Standard 1 was what's called using an area model to multiply polynomials. Area model comes from learning how to multiply. So for example, if we look at something like 12 multiplied by 15, the old-fashioned way of multiplying this would be to set it on top of each other like this, 12 above 15. Take 5 times 2 is 10, so put a 0 there and carry the 1. 5 times 1 is 5, plus the 1 is 6. As we move to the tens place, we put a 0 for a placeholder. 1 times 2 is 2. 1 times 1 is 1. If we add all these columns straight down, we get 0, 8, 1. 180. Today, there's a variety of methods that you learn when you're learning how to multiply, such as the lattice method, or what's called the area model. So if we are multiplying 12 and 12 by 15, we can break that 12 into 10 and 2, because those numbers are easier to multiply. We can break 15 into 10 and 5. So I'm going to label both the top, bottom, and all the sides here. And this multiplication was split into 4 separate rectangles. So I have the area of this rectangle here is 10 times 10. Length times width is the formula for a rectangle. So this gives me 100. The area for this rectangle is 2 times 10, or 20. The area here, 5 times 10, which is 50. And lastly, 2 times 5, which gives me 10. If I combine the area for each one of these rectangles, I get the same answer that I did in the traditional way of multiplying, 180. That's what we're going to do here, only we're going to use exponents as well, and some variables. So in a similar way, when I have this quantity x plus 3 multiplied by x plus 2, I'm going to create a rectangle. And x plus 3 we're going to split into 2 parts, x here and 3 here. And x plus 2 we're going to split into 2 parts, x here and 2 there. Notice I kept the signs, so positive stayed positive. To find out the area of each little box, I'm going to multiply length times width. X by x gives me x squared. If you're not super familiar with how to multiply variables, remember that x by itself has an invisible exponent of 1. When you multiply variables, all you do is add the exponents. So 1 plus 1 gave me 2. The area of this box down here is 2 by x, because the formula is length times width. This gives me 2x. And the area of this one on the right is x times 3, or 3x. And finally I have 3 by 2, which is 6. To figure out the total area of all 4 boxes, I'm going to add these together. So, x squared plus 3x plus 2x plus 6. So, earlier on in this standard, we learned how to combine like terms. It turns out 3x and 2x are both x terms, so we can combine them. And our final answer should read x squared plus 5x plus 6. Let's look at one more problem. It's a little bit longer. Here I have x squared plus x minus 2 multiplied by negative x minus 1. So I'm going to create a box that's going to be 3 by 2. And my x squared, x, and negative 2 terms divide up this length along the bottom. So x squared here, x here, and minus 2. The negative x and negative 1, the signs come with them, and they'll be along the side here. So I have 6 total boxes. I'm going to find the area of each one. I do that by multiplying length times width. Where do I find the lengths and widths? Right along the bottom and right along the side. So for example, we'll start here in the bottom left. X squared times negative 1 is a negative x squared. If I go up 1, I have x squared times a negative x, so that gives me a negative x. And what's my exponent? Remember, I have an invisible 1 there, so I add 1 plus 2 to get 3. Next column, negative 1 times x is a negative x. Negative x times x is a negative x squared. And lastly, I have negative 2 times negative 1 is a 2, and negative 2 times negative x is a 2x, because the two negatives cancel each other out. That's why this last column, they come out positive, unlike the first two. The final step is to combine like terms. So if I have negative x cubed minus x squared minus x squared minus x plus 2x plus 2, I see that there are two separate x squared terms, and there are two x terms. So when I combine them, I get negative x cubed minus 2x squared plus x plus 2. And that's my final answer.